Assalamu alaikum students, welcome back to the lecture of analytic geometry. Today we are going to learn about hyperbola. The layout of our today lecture is how hyperbola is formed, meanings of hyperbola, real life examples of hyperbola. We also discuss about axes, vertices, latest rectum of hyperbola. We derive the equation of hyperbola and we discuss the comparison of two possible forms of hyperbola. We also learned about the equation of hyperbola with vertex h and k, and then we elaborate all these concepts with the help of examples. How hyperbola is formed? When a right circular cone intersects with the plane, different type of conic sections obtain. One of them is hyperbola. The hyperbola is formed when a plane intersects both naps of the cone but not passing through the apex. As we already discussed details about the ellipse, parabola and circle. Ellipse, parabola and circle obtains when a cone intersects with one nap or when a plane intersects with one nap of the cone. But in the case of hyperbola, the hyperplane intersects with both naps of the cone with the restriction that the plane does not passes through the apex. Both naps and plane does not passes through the apex. Then we have a shape is called hyperbola. We already discussed in our previous videos details about cone, how cone is formed, right circular cone, and about its component. You can find the link below in the description box. Definition of the hyperbola. The hyperbola is the locus of all the points in a plane such that the difference of the distance from two fixed points is a constant fixed distance. In the case of hyperbola, we can see that the difference of the distance from two fixed points is a constant fixed distance. These three things are important. As in the case of ellipse, we see that the sum of the distance from two fixed points is a constant fixed distance. But in the case of hyperbola, the difference of the distance from two fixed points is a constant fixed distance. The two fixed points are called the foci, the plural of the focus of the hyperbola. Here we have two fixed points F and G, and P be the any point on the surface of hyperbola. Then the distance from P to PG, and difference of the distance PG minus PF gives us a constant value. All such points whose difference of distance from these two fixed points F and G is constant forms the shape called hyperbola. Real life example of hyperbola. First example is, if you look closely, you can see how the stitches of the baseball form the hyperbola shape. Here we can clearly see that the stitches of baseball forms the hyperbola. The second example is, if you would notice the outline of our glass, this exactly forms the shape of hyperbola. Third and very important example of hyperbola is the shape of the power plant is a hyperbolic for a reason, and that is because cooling tower needs to able to cool the hot water coming from the plant, and in order to do that it needs good updraft to help create the power that plant does. This hyperbola, we can see that the shape of power plant in the form of hyperbola. And the reason behind this is the hyperbola shape create the that needs updraft, use it to help the run plant conjunction with the other components that create the power we use every day. Actually, we have to cool the water that need updraft, and these hyperbolic shapes help it to cool the water. So without it, we may not be getting usable energy as easy as we are nowadays. This is very important example. Some architectural examples of the hyperbola. Interesting, and around the world people visit these places. First is at the Brazil, the card created for the kids. We can clearly see that this forms of the hyperbola. And the second one is a very famous place at the Japan port of Kobe, Kobe Tower. This also forms the shape of hyperbola. Next we move towards the center and axis of the hyperbola. A point lies midway between the two focus, these two focus, and is called the center of the hyperbola. Focus are the fixed point from which we have to take the difference of the distance, and a point lies midway between them is called the center of hyperbola. Next thing is transverse axis. Axis that passes this transverse axis, the axis that passes through the focus is called the transverse axis. And the second axis that is called conjugate axis is passes through the center and perpendicular to the transverse axis is called the conjugate axis. This axis is called the conjugate axis, which passes through the center and perpendicular to the transverse axis is called conjugate axis. Vertex and asymptotes of hyperbola. A point where hyperbola cuts the transverse axis. Here we have this one is the transverse axis which passes through the focus, and a point where hyperbola cuts the transverse axis is called the vertex of the hyperbola. Next term is asymptotes. Asymptotes are not the part of the hyperbola but show where the curve would go if continually infinitely in each of the four directions. Here we can see that these are the two asymptotes. Second one, and these asymptotes determine the direction when a hyperbola goes infinitely, and we can easily determine the direction of the hyperbola by these two asymptotes. Length of the axis of the hyperbola. We denote the distance between the two foci. Distance between first one is F and second focus is G. Between these two focus the distance is 2c, or in other words we can see that the distance from F to center is C, and similarly distance from G to center is C, and the total distance is 2c. Now the next distance we are going to discuss a distance between two vertices by 2a. Distance between two vertices. Vertices are the points where the hyperbola cut the transverse axis. Here A and B are the two vertices, and the distance from between these two vertices is 2a, or in other words we can say that the distance between vertices and center is a, that is distance from A to center is a. Similarly distance from center to B is also a, and the total distance is 2a. The equation that describe B is equal to square root c square minus a square. Also 2b is the length of conjugate axis. Conjugate axis is the axis that passes through the center and perpendicular to the transverse axis. Here we have x as the transverse axis and y as the conjugate axis. Derivation of equation of hyperbola. Let f and g be two foci and O be the midpoint of the line segment FG. As O be the midpoint of the line segment FC that we call center of the hyperbola, and here we consider center at the origin 0, 0. O be the at origin, and F and G be two foci of the hyperbola, and the line from O through G is called the positive x-axis. From O to G is called a positive x-axis. That's why we call the coordinate of the point G C, 0. As we know that on the whole x-axis the equation of the y is equal to 0. And the next one is a point passes through O and F have a coordinate minus C, 0. The distance from the origin to a focus is C, and due to the negative x-axis we have a coordinate minus C, 0. And we consider P be the any point on the surface of the hyperbola and its coordinate x and y. Now we have to calculate the difference of the distance from these two foci F and G, that is equal to 2a. Now we are going to calculate the distance between FP and second distance PG by using the distance formula. First of all, the distance between P and F. We subtract the x coordinate of P from the x coordinate of P, the x coordinate of F, that is x minus C, that gives us the value x plus C whole square plus y square, as y minus 0 square gives us the y square value. Next, we calculate the distance between P and G. We subtract the x coordinate of the G from the x coordinate of P, that gives us the value x minus C. And next, for y coordinate, we subtract the y coordinate of P from the y coordinate of G, that gives us the value of y squared is equal to 2a. Now we simplify these terms. We take one square root term on the right hand side and then we square both sides. After squaring, we cancel similar terms like y square here, and then we open the square of these binomials. After that, we cancel some more terms. You can verify all these calculations. Now we move forward. Again, we have a square of this term, then we open the square of this xc over a minus a whole square. We open the square by using the formula a square a plus b whole square is equal to a square plus b square plus 2ab, and here we have negative sign, then it means minus 2ab. Then we use this formula and cancel the similar term, and then we divide the whole equation by c square minus a square. We have a right side is equal to 1 and the left side is equal to x square over a square and y square over c square minus a square, and c square minus a square is equal to b square. By using this expression, we have the final equation of the hyperbola, that is x square over a square minus y square over b square is equal to 1. That satisfies for all points of the hyperbola. How we can graph the hyperbola? Here a gives us the distance from center to the vertex on the transverse axis, and b gives us the distance from center to point on the conjugate axis. By using these 2 points, we can draw a rectangle like this rectangle. Here we can see that the distance from center to this point on the transverse axis gives us the b value. We draw this b value, and here we use the value of a, and we draw a triangle, and by using this triangle we draw asymptotes, these 2 asymptotes passing through the diagonal of this triangle. Then by using these terms, as a point a is the vertex point where the hyperbola cuts the x-axis. Here x-axis as a transverse axis, the graph hyperbola makes a rectangle that measures 2a by 2b as a sketching aid, and draw the diagonal. These are the asymptotes. Then we can easily draw the shape of the hyperbola. If we know these 2 terms, then we can also calculate the value of c, as b square is equal to c square minus a square. If we know the value of b and a, then we can calculate the value of c easily by calculating as c square is equal to b square plus a square. By using a and b value, we can easily calculate the value of c, and the c is the distance of the center from focus. These are the 2 focus we have. Then we can elaborate all the terms of the hyperbola easily on the graph. Next term is standard equation of the hyperbola with its center at the origin and vertex transverse axis. Here we have this vertical transverse axis, as we derive the equation of the hyperbola with the x-axis as a transverse axis. Now we on similar way you can derive the equation of hyperbola when the transverse axis is the y-axis. And finally we have the equation y square over a square x square over b square is equal to 1, where c square is equal to a square plus b square, and the equation of the asymptotes are y is equal to a over b into x. Plus minus indicates the 2 asymptotes of the hyperbola. In this case, we have a coordinate of the focus plus 0 minus c and 0 plus c as the on the coordinates lie on the y-axis, and that's from center to c distance. It means we have two values 0 minus c and 0 c, and the vertices in this case is 0 minus a and 0 a. Notice the difference between these this form and when the transfer axis is x-axis. Latest rectum of the hyperbola. The latest rectum of the hyperbola is the line segment perpendicular to the transfer axis of hyperbola through any of the foci and whose endpoints lies on the hyperbola. Basically, a latest rectum of the hyperbola is a line passing through the focus and that and whose endpoints lies on the hyperbola. In the case of ellipse, we have the same definition of the latest rectum. The length of the latest rectum is 2 and 2b square over a. We are not going to calculate the length of the latest rectum. We move towards the equation of the hyperbola with vertex h and k. When x-axis acts as a transfer axis, the first form, and when y-axis acts as the transfer axis, we have this form, where h and k are the coordinates of center. As we already discussed equation, in that case we have the center at the origin 0 0, and in this case we have a center at h and k. Open left and right, this hyperbola open left and right, and this hyperbola open up and down. And the vertices, well, we can calculate the vertices of this hyperbola when the center is at h and k. Calculate by using this formula, h plus a comma k and h minus a comma k. And in the vertical transfer axis case, we can calculate the vertices h comma k plus p and h comma k minus p. Notice the difference between all these terms. And the slope of the asymptote is same in the both cases, that is equal to plus minus b over a, as here in this case the b is the denominator of the y coordinate, and in this case b is the denominator of the y coordinate. But we can notice the difference between these two terms, that in this case y is act as a transfer axis, and in first case x axis act as a transfer axis. And the equation of the asymptotes for these two cases are also same. Y is equal to k plus minus b over a x minus h, where x as h is the x coordinate of the center and k is the y coordinate of the center. Notice all these terms. By using all these terms, we can easily find the vertices, equation of asymptotes, and center of the hyperbolas from this equation. First of all, we have this example. Sketch the graph of each of the following hyperbolas. We have to sketch the graph of each of these hyperbolas, and for sketching we need center, vertices, asymptotes, or slope of asymptotes. First of all, we are going to find about the center. Center of the hyperbola is the term that subtracts from the x coordinate and the y coordinate. Here we have the center, that is equal to 3 minus 1. As we have the subtracted value, that plus 1, we can write this plus 1 as minus 1, and a value subtracted from y gives us the coordinate of the center, y coordinate of the center. And here we have a and b. A is 25 is the square of 5, and 49 is the square of 7, and here we have the value of a and b. We can easily see that in this case of 5, value of a is 5 and b is 7. In this case we have the vertices, as we have the vertices h plus k comma h plus a comma k and h minus a comma k, as we discussed above about the vertices. And the slope of the asymptote are equal to plus minus b over a, that is equal to b, value of the b is 7 and value of the a is 5. We have the equation of the asymptotes. We can find the equation of the asymptotes by putting the value of a, b, h and k in this equation, and we find the equation, these two equations of the asymptotes. Finally, we have all these coordinates, and we can draw the hyperbola easily, as we can see here. Here we can see that vertices are the points where the hyperbola cuts the transfer axis. And this hyperbola cuts the transfer axis at a point 8 -1 and -2 -1. And we have the point at -1 and -2 -1 where the vertices cuts the x-axis. Next example is sketch the graph of each of the following hyperbolas. Again, we have to sketch the graph of this hyperbola. Here we can see that the denominator of the x is 1 and the denominator of the y is 9. And denominator of y is equal to b square, that is b is equal to give us the 3 value, and a square gives us as a square is equal to 1, and a gives us 1 value. And the center in this case gives us the value of -2 and 0. And we can calculate the vertices here as we have the y square over b square minus x square over a square form. It means the transfer axis is the y axis. We can find the vertices by using the this h comma k plus p as we discussed above in the comparison table, and we can find the slope of the asymptotes. After that, we can easily find the equation of the asymptotes, and we can draw the hyperbola, this shape of this hyperbola. You can easily draw the shape after calculating all these terms. You can also calculate the focus of this hyperbola. Thanks for watching. Hopefully this video helps you to understand the concept of hyperbola. Stay in touch and stay home, stay safe.